My name is Nathan Howe, and I wear many hats at Zscaler. And first, I must apologize that I'm doing this in English. I'm Australian, and unfortunately, German is not my mother tongue. So I appreciate your patience with English. As I said, I wear many hats at Zscaler, and today I'm going to talk about the Zscaler Private Access, and in terms of what it really applies to in the world. We talk about how it can be applied, how it can help enterprises at scale. And I'm going to start by talking about Zscaler Private Access in relation to what it really is. And to do that, I want to set the ground to ask you a question to think about yourselves. Why do we actually have jobs in IT? Why do we work in IT at all? What is the actual reason why IT exists to this day? And obviously today, with the ongoing COVID-19 problems, it's more and more important as we're setting a new trend for the way in which we are working. But ultimately, what we do within our industry is we are connecting users, people, to information, and information is stored somewhere in an application. And you think about it in terms of anything, whether that be providing connectivity for your users to a Google search, or whether it to be an email client, any of these things are allowing you to be able to provide access for your users to this information. What this means, though, in general, is we've always had to connect those people to a network. And what I mean by that is, if you think about the way in which applications work, you need to connect a user to the same network space where that application is. And this is the reason why we've always had our applications inside a trusted network that users could come to the office and plug in their computer and be on the trusted network and get access to that information via that application. The challenge, though, that has become very apparent over the last few years is that what happens if we need to add more and more applications in different network segments? We have to interconnect more and more networks. And this has become very clear in terms of companies moving into multi-cloud environments, companies with partnerships, companies with multiple application spaces around the world or in different cities and different locations. So how does this change the way in which we provide access for these users? And for that, we have to really consider the way to move forward. So one of my goals of this conversation over the next 20 minutes or so is to really give you some insight as to how to get away from these buzzy buzzword things and understand what it really truly means. And I'm really going to keep coming back to that user to application access. I think that is the critical conversation we want to have. But there are some things I just want to define here and so it's understood. There are a number of terminologies I'm going to be using, things like VPNs and how we utilize those through network segmentation and isolation. The next generation of this was called software-defined perimeter. So that's where we've kind of started doing some isolation around access and essentially moving the protection perimeter closer to the client. And then moving into the next evolution, which is the idea of zero trust. And this is the buzziest of buzzwords that are out there right now. Everybody's talking about zero trust. I'm talking about zero trust, is even in my title. But it's important that we discuss it as a framework and not as a standard. There's a lot of different understandings need to be considered here. And finally, the new hot button item is the Secure Access Service Edge, SASE, as is known to be. So I'm going to cover those in some explanation as we go through this. And to show you this, I want to go through a journey, and I want you to consider a very simple example. Here we have a diagram of a traditional company network. And as is the case probably for all of you at the moment in 2020, we have to connect people who are anywhere. And in this case, there are people in these branch offices who we connect over a trusted network. And then there are people who are not on the trusted network. We need to connect them to applications in the middle, SAP and so forth. So what we've done in the past is we've built some sort of VPN gateway. Now, why do we do this? Because we want to connect the user, wherever they are, outside the company walls, to the network where the applications work. And so here's a representation of some of those controls that are required when you expose a VPN to the internet. Now, this is just an example. You may have more or you may have less. It's just a representation of what is possible. But the reason why you've had to put these controls in place is that you're now connecting people from a network that is not trusted, that's the internet, into a network that is trusted, your private network. The problem we have there, though, is that as soon as you expose that ecosystem to the internet, you need to protect yourselves because anybody can connect to that gateway. Anybody can find your VPN gateway. So that's why we have controls like DDoS protection and global load balancers and so forth. What's interesting, though, is when you start considering that connection flow and how we get users in, what we are essentially doing is extending our network to the user, wherever they are. So we're creating a logical network connectivity between the user and the network where the applications are. This becomes an interesting situation when you have more than one application location. And as I mentioned in my first slide, there is this path we have to consider. What happens when you have applications outside of your controls? Beyond the actual bounds of your physical application? Is it an extended network? Is it, as the diagram here shows, is it cloud-based services? Because the problem here now is that user is now technically on the trusted network. And so if something malicious is to happen, and this is, again, representational, that this bad thing, it's an icon of a virus, which I guess is probably very timely, has the ability to move because the user is sharing that trust of the trusted network. And it doesn't matter whether it be malicious content or whether it be someone just trying to browse around and find their way around and explore, there is an implicit trust here, and that is shared across this ecosystem. So this is the situation we've faced for many years. But then came along about 20 years ago, and many of us have actually implemented this in some way, the idea of the real first implementation of zero trust. And this came about from the theory that was called, based on the Jericho project, a group of very intelligent people working across multiple different companies came up with a theory of how to provide this granular control and segmentation. But the technology has always been the part that has lagged behind the theory. And so the first thing we did was say, hey, these are segments of networks or segments of ecosystems, and I'm a network segment that I want to isolate away. So what I'll do is I'll make sure that the people who are not allowed to access this can't even see it. And essentially, the same story plays out here. You still have that remote user, but those segments are now dark. They have no way of connecting to them. That trusted network is only exposed in a certain way to the users. And it's the case here, if that malicious traffic was to try and pass again, you'll see that it doesn't have the ability to get to those trusted environments because they're isolated. There's no way for them to get there. This isolation is the first real step towards the idea of zero trust. And let's be clear, zero trust really comes down to the idea of least privilege. And for those of you who've been around in the industry for a while, least privilege is a fundamental feature of the core operating system of the internet, which is Unix and Linux. So the idea is there, but the implementation has never been properly executed across the multitude of the internet. So let's talk about how that situation plays out in terms of providing connectivity. And if you think about it, and this is probably a very important slide to consider given the circumstances at the moment. If you have a control set of infrastructure here, you have a number of different physical controls in place to make sure your network is protected. The moment you have a certain subset of users using it, and most companies, when they build this remote access service out, consider between 10 to 30% of their workforce being remote. Clearly, that's changed a little bit over the last few weeks, and we need to consider what happens when we need to add more users. How much more do we need to add to our ecosystem? Do we need to consistently add more infrastructure? Because obviously more infrastructure and that scale of adding more larger boxes, more policy, more locations becomes complex for anyone trying to utilize and manage this ecosystem for their users. And you end up having to put a lot of constraints in your ecosystem, things that actually would be quite challenging. And I've seen this, we've all probably seen this in the last few weeks, is how quickly can we scale to bring in new connections from our remote users. Interestingly enough, and a large number of the physical vendors out there that provide boxes have substantial back orders, and that's very good for them. But they have substantial back orders from customers waiting for new infrastructure to handle the oncoming load of users working from home or working remotely. And as I was reading yesterday, now 1/3 of the world's population is now isolated and segmented and working from home under lockdown. So how do you then scale when we need to go to the full population or the working population exists? So we need to consider this when it comes to managing that scale. And clearly that's what I'm trying to talk around is not a good thing. One other thing to keep in mind about that VPN is that it locks people into locations. And I think that's probably a very important discussion to have in regards to your users as they move. Obviously, when you build a physical box, there is a physical link to that service. And that service it will be in a certain location. So that when you have people perhaps in Europe, they would be logging into, or in Switzerland, they'd be logging into a Swiss system. If that person happens to be in Hong Kong for whatever reason, not that there's a lot of travel right now, but then they would have to then connect all the way across the world to that Swiss system. And this is the physical restrictions that come into play with the old world technologies. So let's talk about true zero trust architecture and what it really means. And to do that, I want to come back and talk about 3 key fundamental points to zero trust. And I'm going to put everything on screen and discuss them all. If you think about a way in which a traditional access path would require, I mentioned this at the top of the presentation, people are able to connect to your VPN gateway. Anyone on the internet can connect to your VPN gateways. That means they can go up and make a connection and knock on the door and see if it's open. And recently we've had, unfortunately, a number of vulnerabilities shown in a number of VPN services, and it's led to some bad compromises and so forth. But that shouldn't be the way. And that's why zero trust is critical. Zero trust actually says that if you are not an authorized user coming from an authorized device, going to an authorized application, then you don't get connectivity. And that's a critical difference between a zero trust model and a traditional access path. That in the initial build of the connection from the user to the application, there's a validation of who the user is, what the device is it coming from? Is it a trusted device or is it an untrusted device? And what is the application? And these 3 things, taking the context based upon those information and based upon the policy that is built, will allow the user to be able to see the application and then access it. If they're not allowed to, they won't even know that it exists. And it's these 3 fundamentals that play out so importantly to the zero trust model. And it's something that we see a lot of information out in the market about this, but it's clearly where the industry is shifting. And I hate to say that, even though this number from Gartner was quoted in 2019, more than likely this is going to shift now because we're seeing that obviously with more and more people working from home, industries are reconsidering how they're providing these access paths. So let's talk about what we should consider when it comes to zero trust. And I'm going to come back to the idea of the users. Now, the critical piece on this is you should know who is accessing what. Now, this is actually really easy because whilst most companies have a large problem in generally handling identity, the good thing is by creating a new system, you can add people freshly to it. So what I always recommend any of my customers or prospects when I talk to about this, I always recommend that they define a set of people they'd like to begin the process with. Take 10 people, take 50 people, put them in a group them together with a similar goal, and allow them access for the process. Then comes the other half of the equation. What is it they're trying to access? What is the application that the user is trying to connect to? Now, more often than not, most enterprises, again, don't have an accurate inventory of every single application. So how can you build a policy saying users go to applications? Again, this is why I actually will challenge most enterprises, and I challenge you to think about this whilst I'm talking now. What is actually an application? 10 years ago, I would have easily said that Microsoft Outlook was something that existed on one machine with one IP address, and maybe ran TCP port, was it 110, so POP and SMTP on 25. But more than likely today, if you are running still Outlook on Exchange on premise, it's not just one IP, it's probably 20 IPs, it's on probably 20 different boxes. There's probably an SQL service, there's a web service, there's a whole bunch of other services that are running to maintain the outcome, which is a mail service. So what's the application? Is Outlook, or is Exchange all of these things together? Or are you defining access on just one SMTP or one SSH or one web service and so forth? So what an application is doesn't need to be as specific as one port, and I would actually argue it's broader than that. It's probably a segment, a portion of your network, a domain space, an IP space, And what goes within that needs to be granularly decided afterwards. But you have to start somewhere. Finally, you need to consider whether the users are allowed or not. So this is policy. So you know the users, you know the application, what's the policy you're going to define. And what this means then is you can define this access control on connectivity without the need for a network anymore. So as I mentioned, if you can identify the users and really put them into a simple group and leverage an identity provider like an Azure AD, an Okta, a OneLogin, a Ping, any of these things will allow you to be able to have that grouping and manage those users very simply. And know your applications. As I said, it's very easy to be able to define these if you have an idea, a general, like we know that we have an ERP system, and that is this space. The advantage of a zero trust model is that when you start providing access, you'll see that things perhaps aren't working as expected. And you'll see, oh, this part of the communication didn't work because it wasn't going through zero trust. So you just need to add it. And it's very simple from a process point of view. So let's talk about the zero trust architecture like that diagram I showed a minute ago. And this time around, though, I'm going to actually show you that there is no infrastructure. Like famously was said in the Matrix, there is no spoon. In this situation, the user has no idea where that infrastructure is. And in fact, there is no connection for the user to any network whatsoever. Actually, what happens is when the user wants to access an application, they go to what's called a broker on the internet. And that broker is basically a piece of software that brokers two connections together after the user is authorized. So what we see here is a connection from the user and a connection from the application. And these two are brought together in the middle. Think of this like an old telephone operator, looking really back into like the 1920s, 1910s, long before any of us were born, where you would make a telephone call by ringing up an operator and saying, can I please speak to my friend? The operator would check to see whether you were allowed, and if you were allowed, the operator would take two cables and plug those together. Same exact mindset here. Those two cables are being plugged together, although they're not cables, obviously. They're tunnels. They're encrypted TLS tunnels, but they're done per application basis rather than a network basis. So this gives you the ability to then actually have multiple connections coming into the one user. Think of it like this. We're on a WebEx right now. None of us are connected to each other, but we're all coming together in the middle point, which is the operator, which is the WebEx service, and we're able to communicate. You're able to listen to me, ask questions, have a conversation. And that's exactly what this is doing here, but not just for voice or for video. We're talking about every possible TCP or UDP application. The advantage, though, is that the users are not ever forced to go to one location. The applications are all, it can be anywhere, and the user can be anywhere. So I've mentioned the theory, and I'm going to quickly run through Zscaler Private Access as a platform as what it is. I've mentioned this before. The idea of zero trust and with ZPA is much different than what today is. Today, you pick up your phone, you have someone's telephone number in it, you can go, you tap on it, you ring them. You want to browse a website, you go to the website directly, you know that. But in the old world, we had this process where if I wanted to call someone, I needed to call that operator on a switchboard. And then once they validated me, they plugged me together for that conversation. That is exactly the same as how zero trust works with Zscaler Private Access. So we have a global operator, a global switchboard that validates all controls that are set by your company. And when a user wants to access an application, only if they're valid will that policy enable access. And when it's enabled access, that connection will be enabled on the fly for that session. Now, this is done thousands of times a second for each individual user because we're creating individual connection paths for each application access request. And this is really cool because you never actually have to worry about connecting people back to the network. So in terms of the world today, you don't have to bring people onto a VPN or onto a network. You can just provide application access, provide its policy engine. And there are multiple use cases to consider here. Whilst we're talking about VPN replacement, it's certainly one of them. But keep in mind, if you are actually connecting users to applications, third-party access is a possibility as well. So is connecting users to the multiple clouds or other things. The really powerful ones are like mergers and acquisition, where you can actually provide granular control of users going to apps without ever needing to connect networks. Things like APNs on handheld devices like for delivery companies and so forth, they can go away, and also providing access to industrial control systems. So let's look at ZPA very simply and how it works. All we need to do is have a user running the Zscaler app, our traffic forwarder, and we have our connectors. Now, our connectors connect outbound. Everything within Zscaler is an outbound connection from the connector at the top here, and the users on the Zscaler app connected to the Zscaler cloud. And much like the operator model, the policy is decided in the middle when the user makes a request for access. So when that access is actually enabled, what actually happens is those two tunnels are connected together for that application to flow, and it just flows across it. The user is not aware of where that application is or where that network is. So scale really shouldn't be something you need to worry about. And I'll put this up as to show you just very briefly. I've mentioned this already, but the idea of this is that there's no infrastructure required in a service like this. With Zscaler Private Access is purely cloud-based. So when we need to add more scale, we add more scale. And over the last few weeks, as we have seen, like everybody else, a substantial increase in requirements to connect users, we add more scale, and our users don't see the difference. We add more customers, we add more scale. There's no visibility to the users. They don't need to go and install hardware, buy new VPNs or firewalls. We scale for you on your behalf. It doesn't matter where your users are. We are the service that continually scales up for your users. So we have a program that we've released, obviously, as part of this overall response to give customers the ability to build true business continuity. That includes a very simple contract of 1 year, probably a very simple and easy 3-month clause to get out should the service not be to your liking. But what's the most important thing here, and that's why we partner with Advantech, is the rapid deployment service. You don't want to pay for a service and wait 5 months for the hardware to arrive or for the configuration to be done. You want to pay for a service and get it working right away. And we have some very good use cases that are publicly available on the internet. We've talked about, I'll mention the company Dfs Architecture, who went from being a Zscaler Internet Access user with no Zscaler Private Access. And then they decided on a weekend they were going to put all of their users on ZPA. At the end of that week, so 7 days, we had all of their employees. That's 44,000 employees working on Zscaler Private Access remotely. So it took us a week to deploy that scale. And it's very possible to go bigger. I can't talk about those examples, but they're there for sure. So the next step is for you to go, if you'd like to know more about this, please do go to the link here, zscaler.com solutions work from home. And then you're also very welcome to request an architecture session from Advantech or from ourselves in Zscaler. And we're very happy to give you some insights on that. The deployment steps are very simple. So we want to move very, very quickly. So it's a process of 2 days of scoping, configuration, and then obviously moving a pilot into production. So the Dfs Architecture example was a pilot was for 1,000 users, and within a day that became all of the users. So it's very quick and easy. Again, there is no implication on you as a customer to install any hardware. There are some virtual machines to be required to be set up. Those are the connectors. But it is a very simple deployment, and it's meant to be frictionless for you. Again, if you have any questions, please do let us know. Finally, we want to do this to make sure that our customers are not only safe. We do hope that you all are staying safe at this time. It is important that we create a level of trust, not just from a technology point of view, but as a health point of view. For us, we're really very focused on driving the ability for connectivity for our employees, our users, and so forth. We all are, from Zscaler, all connected with our service. We all believe in the service, of course. So we eat the food and we walk the talk that we believe in. So with that, I want to just quickly show you one last thing, which is talking about the overall Zscaler package. And there's one thing that I'd like to discuss. We have Zscaler Internet Access, which we haven't talked about today, but that's not a problem. Zscaler Private Access, we have talked about. And finally, Zscaler B2B. And this is a new platform. This is our connecting our business-to-business connect users. So that being, if you have an integration between partners and you'd like to be able to share application access without actually ever exposing your network, we have a B2B platform as well. So I'm sure that will be very interesting to be able to go into details with quite a few of you there. One last thing is that with all of this, there's a lot of information flying around. and there's a lot of data that needs to be understood. And what we are delivering at Zscaler is a thing called the Zscaler Digital Experience, or ZDX, which is an end-to-end monitoring of all applications to make sure that when your user does request an application, not only are they going to get there with the Zscaler platform, we're also going to know what could be possibly causing them problems. Is it their home Wi-Fi? Is it their SaaS provider, and so forth? And that's something I think we're very interesting. It's a full end-to-end monitoring of all application access. All right. With that being said, the three things I ask you to remember: there should be only one network, that is the internet, nothing more. Your security should be ubiquitous. Your users should have the same security, whether they're on network or off network. They should always be secure. And finally, we have to protect them, not just from the internet, but also physically when they're at home and also in their health. So we need to make sure we drive the right attitude towards not only working, but their healthy lifestyles as well. So yeah, safety is very sexy, as it says here.
Guten Morgen an alle Teilnehmer. Herzlichen Dank auch an Nathan für die Präsentation. Und ich möchte Ihnen kurz zeigen, wie wir zu Zscaler Private Access gekommen sind, der Weg. Ganz kurz die Firma. Ich hoffe, dass alle Sie kennen. Momentan leider keine 61 Warenhäuser und 27 Restaurants, sondern nur 31 Food-Supermärkte in Aktion aufgrund der jetzigen Lage. Sonst ja, sind wir die größte Warenhauskette in der Schweiz und hoffen, wir bleiben es auch nach der Krise. Unsere Ausgangssituation: Wir haben eine klassische Rechenzentrumsarchitektur mit zum Teil outgesourcten Prozessen. Heute heißt es ja modern Cloud, damals hieß das noch Outsourcing, und mit einer klassischen VPN-Client-Architektur für Notebooks, Windows, macOS, für Benutzer unterwegs. Das ging lange Zeit gut, aber es gibt neue Herausforderungen. Einerseits haben wir eine ganz klare Cloud-First-Strategie, mit Ausnahme des POS, also dieser ganzen Kassensysteme. Und Zero Trust ist auch eine Herausforderung für uns, gerade im Warenhaus, wo sehr viele verschiedene Systeme zusammenkommen können. Sie haben da neue Geräte, die Sie zeigen möchten. Sie haben Geschäftspartner, die eigene Geräte dort haben, Sie verbinden möchten. Die möchten Sie vielleicht nicht ganz auf Ihrem Kernnetz haben. Das heißt, Zero Trust als Schlagwort oder als Ziel ist da sicher eine gute Sache. Okay, sorry, ich habe ein Problem gehabt mit dem Folienwechsel. Wir sind Zscaler-Kunde seit Ende 2013, ganz klassisch über Zscaler Internet Access. Das war ein Entscheid damals von der On-Premise Internetschutz zum Cloud-Based Schutz zu wechseln. Da haben wir uns für Zscaler Internet Access entschieden und sind seitdem auch dabei. Im Juni 2016 hatte ich das Vergnügen, Manoj Abte von Zscaler zu treffen an einer Tagung in Bern. Und wir haben da ganz unverbindlich über eben Zero Trust diskutiert und er hat damals mal gesagt, ja, wart ab, bei uns ist das im Tun, das könnte sehr interessant werden. Ich habe dann das mal nicht weiterverfolgt, gedacht, das kommt schon sowas. Und siehe da, einige Zeit später war es dann wirklich soweit. ZPA wurde vorgestellt, eingeführt und wir haben uns dann entschieden, das mal zu versuchen. Es gab einen ZPA-Workshop und Proof of Concept, auch unter guter Mithilfe von Nathan, den Sie vorhin gehört haben. Das war insofern erfolgreich. Wir haben dann einen Piloten gestartet und das Feedback der Benutzer, das war wirklich, das ist mal eine coole Sache. Es ist unsichtbar, ich kann einfach arbeiten. Währenddem wir mit der klassischen VPN-Architektur, sagen wir mal, das möglichst leicht gemacht haben, aber man musste vom Notebook immer sich connecten und wir hatten dann ganz coole Benutzer, die auch in der Firma selbst das VPN noch gestartet haben. Also super verschlüsselt. Und mit ZPA gab es dann doch so, ich starte mein Notebook, ich bin einfach drin. Es gab einige Stolpersteine, einige Holperer drin. Wir haben zum Teil eine Proxy-Legacy-Architektur, das heißt, wir hatten gewisse Applikationen bei Partnern, die haben ein IP-Fencing, das heißt, die haben geschaut, dass nur eine bestimmte Internetadresse zulässig ist. Das mussten wir dann entsprechend einbauen, hat aber geklappt. Und ein zweiter Stolperstein, den wir zusammen mit Zscaler sehr gut lösen konnten, das war unser VPN. Das hat uns zum Teil unsauber deinstalliert und hat dann zu Mausflaggen geführt bei den Benutzern. Das war nicht schön, aber wir konnten auch das beheben. Mittlerweile, so, das Rollout, das haben wir relativ konservativ gemacht auf den Notebooks und haben uns dann entschieden, nicht alle aufs Mal zu machen. Wir sind auch dran, Notebooks neu aufzugleisen, das ist komplettes neues Hardware-Rollout. Das heißt, wir haben uns dann entschlossen, Notebooks, die zurückkommen bei Benutzerwechsel, werden neu aufgesetzt. Neu bestellte Notebooks werden ebenfalls mit ZPA ausgestattet und die anderen werden jetzt im Rahmen des großen Rollouts weitergeführt. Momentan Notebooks, wie ich das gesagt habe, es ist auch so, dass ZPA nur auf den Firmen-Notebooks verwendet wird. Eine Ausweitung auf Privatgeräte, sage jetzt mal, ist angedacht. Siehe auch den Ausblick auf die Zero-Trust-Architektur oder Enabler für weitere Devices. Das werden wir jetzt in Ruhe anschauen. Momentan sind wir sehr froh, dass wir ZPA haben. Wir haben jetzt einige Leute auch im Homeoffice und Tendenz steigend. Und die verwenden im Moment 50-50, noch das klassische VPN und ZPA. Aber das hilft uns und wir haben mit ZPA momentan, das darf ich auch ruhig sagen, keine Verbindungsprobleme und auch keine Performance-Probleme. Und das, denke ich schon, ist ein Kompliment auch an Zscaler. Man muss die Anwendung gut einführen. Ich denke, dieser Einführungsplan, den Nathan gezeigt hat, das macht Sinn. Ob's bei allen, ich glaube nicht, dass wir garantieren können, dass es bei allen so innerhalb dieser kurzen Zeit geht, aber es ist möglich. Und Ihre Benutzer, wenn Sie sowas einführen, ich denke, das Echo wird genauso wie bei uns sein. Es ist eine gute Sache. Und es hilft aber auch, nicht nur den Benutzern das einfacher zu machen. Für mich ist es auch ein Schritt, um sicherer zu sein und offener zu sein. Und das werden wir jetzt so weiter ausbauen und sehen, was die Zukunft uns bringt.
Vielen Dank, Herr Schmidt, das war sehr spannend. Dann gehen wir jetzt gerne zur Q&A-Session über. Nun zur ersten Frage. Können sich auch Dritte wie Lieferanten via ZPA anmelden und wird alles für die Revision bzw. Compliance aufgezeichnet oder geloggt?
The Zscaler Private Access platform, and I hope I answered the question correctly. So with Zscaler Private Access, the ability to provide compliance policies to users actually is quite simple. And then to define and enforce whether you'd like to lock people in or out does come down to individual controls. So there are ways to do this across different functions, whether it be an application access control or whether it be a timeout access control. But it really comes down to how you'd like to do that. It's actually, we're very flexible in terms of those things. To add a piece in terms of the overall compliance, there's two critical pieces I want to call out. I'm glad that the question came, is that With Zscaler Private Access, all data is passed across encrypted tunnels. There is no visibility of anyone or anything along the way. So any data leaving the client device and passing through the connectors and egressing into the network is encrypted. And this is encrypted using mutual TLS. And it's a temporary connection that's only for that session. It's not permanent like an IPsec session. So we're ensuring the integrity of traffic along that way. And the second part is that we have no idea, the Zscaler has no idea who the users are. We will receive a user value from the customer. That could be a connection like, it could be a username, it could be a string or so forth. It's up to you. So we're able to be very compliant in those regards. But I think this, in terms of this question, would be much more complicated of an answer than yes or no. So I'd be happy to dive into more details as a secondary call.
Okay, great, thank you. Wir haben eine Frage für Herrn Schmid erhalten.
Ja.
Die Frage lautet, wie haben Sie das eingebaut? Also wenn ein externer Host erwartet, dass von einer dedizierten IP zugegriffen wird. Das Problem haben wir eben auch.
Das haben wir momentan einfach gelöst. Wir haben in ZPA arbeiten wir mit, auch mit Proxy. Das heißt, wir haben so eingestellt, dass diese Anwendungen oder diese Zugriffe leider immer noch über unseren On-Premise Proxy erfolgen mit dieser bestimmten IP-Adresse. Das ist im ZPA so eingestellt, also ein Bypass. Nicht alle auf der anderen Seite sind bereit, die ganze Zscaler Breite freizugeben. Da müsste man allenfalls diskutieren, ob man Zscaler Zürich zum Beispiel freigeben könnte, wollte. Aber wir können momentan nicht alles, was über den Proxy läuft, ablösen. Aus diesem Grunde haben wir uns für diese Lösung entschieden.
Okay, prima, vielen Dank. Ich habe gerade noch die Rückmeldung erhalten. Okay, so ist es bei uns auch noch. Danke, das kennen wir.
Okay, ich habe leider keine bessere Lösung.
Okay, vielen Dank, Herr Schmid. Nun zur nächsten Frage an Nathan. Sind schon Erfahrungen zu ZPA-Clients auf Mobiles, also iPhone, Android, für Zugriffe auf interne Web-Applikationen oder von Mobile-Apps auf interne Applikationen, zum Beispiel ABA-Click-Client auf Abacus, in Klammer ERP-Lösung, vorhanden?
Yes. So Zscaler Private Access, the client runs, and to be clear, the Zscaler app client runs on Windows, Mac, but also, as pointed out in the question, Android and iOS. And we forward any application that is TCP or UDP based. So any of those applications will work. What we tend to find is that the most important thing when using mobile applications is defining what you would like to send to Zscaler versus so via the private path or via the internet path. Your decision as the policy is to which way you send it is up to you. But ultimately, the answer is yes.
Okay, great. Thank you very much. Die nächste Frage an Nathan in English. How do existing customers and their users rate performance and ease of handling?
That's a good question. So the one thing about this is it's always a matter of comparing like apples to oranges. And as we say in English, and I think that when I look at the last say 2 weeks, and we have had basically every one of our customers turn all of their users on. The large majority, in fact, the large majority have been very, very, very happy with the performance of their connectivity. The advantage is, and then this is why it's apples to orange, is that because there is no dedicated path that everybody needs to connect to. So if you think about a traditional VPN or a traditional access connectivity path, everyone has to connect to that network and leverage that network to be able to get access. And that can overwhelm that network when you have too many users and slow things down. Or if a user's coming from another part of the world, it obviously they have to still come back to that central location, and there's latency involved. With the Zscaler Private Access platform, users connect just to us, and we bring the applications from wherever they are to them. So it makes it a much more friendly experience to users when they try to access applications. And ideally, when you do roll out Zscaler Private Access, you should do it in a transparent mode so that users will never see it. A successful rollout, it means that your users just have been told, you have a new way of working, go for it. And that's it. They will never see it, never understand it, never touch it. There's no need to log in like they do with a VPN. Zscaler Private Access integrates with single sign-on, so it's simple for users. It really is the key here is simple, secure access to apps. And that's what we do. So the ultimate answer to the question is yes, we provide very good performance and we have very good feedback from our customers. I only recommend for you to, if you'd like to have a look at resources, have a look at LinkedIn and from some of the comments we had from DB Schenker amongst other customers recently about the performance of this for their environment.
Okay, great. Thank you very much. The next question is, Zscaler Private Access just seems like a smart reverse proxy service. How is it different to other services out there?
It's an interesting question. So let me be very, very clear. Zscaler provides two services. And Zscaler Internet Access is a proxy-based security solution, and that's for traffic going from your users to the internet. Zscaler Private Access is not a proxy service. It is a zero-trust platform that does not understand and does not want to. We do not want to understand or proxy any of the traffic of your private applications. So Zscaler Private Access is actually much smarter than a proxy. We don't want to look into the applications themselves, but we're able to make intelligent decisions about how to steer traffic based upon where the user is, where the application is, the latency response time of the user to the app, and so forth. We can figure this out and figure out how to best steer the user. Ultimately, we're providing a trusted path more than anything else. So proxy, reverse proxy also has a very large problem in that in order to have a function like a reverse proxy, you need to expose that to the internet so people can connect to that front end and access the application. With Zscaler Private Access, there is no exposed infrastructure. Your users connect to Zscaler, and Zscaler provides a functional path from the applications to the users. So there's no exposure there. Now, I can go into much more details about proxy rewriting applications and so forth, but I think that's another 5-hour WebEx, and we don't have time for that today. But I'd be very happy to go into those details as well. But in short, we don't do any proxying of private traffic. And we make sure that traffic is completely private and only available to and only accessible to people who are authorized to access that through the Zscaler platform.
Great, Nathan. Thank you very much. The last question is, this COVID-19 scenario, beyond the important human aspect, puts quite a few business into challenging situations. You mentioned that you scale, but really does Zscaler have the ability to scale?
Yeah, that's a really good question, and I think it's very valid at this time. As I mentioned in my presentation, that the situation is definitely putting a lot of stress on everybody worldwide. Businesses are trying to figure out how to connect users and provide new ways of working and so forth. To be very, very clear, Zscaler has, over the last 2 weeks, seen an exponential amount of growth in our connectivity by users. I don't have the exact numbers at this very moment, and I don't think I'd be sharing them right away. But I can tell you that we have seen, just in pure number of users connecting, from 2 weeks ago until today, it's something like almost 1,000% growth over that ecosystem, and we don't have any problems. We are actively monitoring to see which countries, for example, next to implement a lockdown. And by doing so, we can actively or proactively scale up infrastructure. So Zscaler is not, we're a cloud-based service where there's no need for us to go and buy hardware and implement hardware somewhere. We can very easily scale our service up wherever we need to. And just as a simple example of what can happen is last week in Frankfurt, we leveraged some of our services from cloud providers as well. And there were some problems with those cloud providers that caused an impact to us. But our customers didn't see that because we have multiple layers of redundancy in place so that when that issue happened at one of our cloud providers, we failed over to another environment that was already available and the users were unaware. And we just kept scaling out and adding more. So the ultimate answer is yes, we can scale. We're doing it at ridiculous numbers right now. And I would believe that not just from COVID, but also as people become aware that working from home is actually a good thing, actually a possible thing, and actually a very, well, overall good thing for the world. I mean, I know we need to interact with each other, but it's also nice to have clean, fresh air outside and so forth. I think it's important that we realize that we can actually meet that scaling requirements for anyone. And we take great pride in that. Our name literally means, Zscaler means zenith of scale. So yes, we are scaling, we will scale.